Welcome to Study Loop.
So the monoprotic acid given here will be dissociated as H plus and A minus. So this is the acid and A minus is its conjugate base. And based on the concentration of the acid and its conjugate base, we can easily say whether the pH is less than or equal or greater than pKa. So first rule is, if the concentration of this acid is greater than the concentration of its conjugate base, then pH will be less than pKa. Rule number 2, if acid concentration is equal to its conjugate base, then pH will be equal to pKa. And rule number 3, if acid concentration is less than the concentration of conjugate base, then pH will be greater than pKa. So we have to remember these three rules while answering the problems. So in first one, we have 0.1 mole HA and zero point zero 0.05 mole A minus. That means the concentration, and since both of them are in 1 liter solution, then the greater number of moles will have greater concentration. That means since the acid's number of mole is zero point 0.1, which is greater than 0.05, that means we have the acid concentration higher than the base. That means in this case pH will be less than pKa. In second one, we have 0.1 mole HA and 0.15 mole A minus. That means conjugate base concentration is higher than the acid concentration here. That means pH will be greater than pKa. Now in third one, we have 0.1 mole HA and 0.05 mole OH minus. And since OH minus is not the conjugate base here, that means 0.05 mole OH minus will react with 0.05 mole HA to reduce the HA or the acid concentration to 0.05 mole. That means that um, the final acid concentration will be zero point 0.1 minus 0.05 equal to 0.05. So this will be the final mole of HA, and the final mole of A minus will still remain 0.1 mole. So that means that oh no, in this case the final concentration or the final number of moles of A minus will be also 0.05, since already um, 0.05 mole hydroxide ion have consumed 0.05 mole HA. That means in the remaining solution we have 0.05 mole HA and 0.05 mole A minus. That means in this case the number of mole of HA and A minus is same in the same volume. That means in this case pH will be equal to pKa. And then in number D, we have 0.1 mole HA and 0.075 mole OH minus. So we have 0.1 mole HA, and since we have 0.075 mole OH minus, that means in the resulting solution, our acid concentration will be 0.1 minus 0.075. That means the resulting number of moles will be 0.025 mole Ha, and the A minus will be the number of moles of hydroxide ion added. That means 0.075 mole A minus. So here you can see that the base concentration is higher than the acid concentration. That means we will have to apply this formula. Then pH will be greater than pKa. For case D, pH is greater than pKa.